All right, so to reiterate what I said earlier in slightly different words, a confounded experiment, or when we say that there is confounding present, what we're saying is that the results of the experiment could be attributed to either the independent variable or to some possibly undefined, unknowable extraneous variable. So, for example, if our study shows that memory for pictures is better than memory for words, it's possible that the independent variable is responsible, that in fact pictures are more memorable than words. That's possible. But it's also possible that there's some extraneous variable, like for example, maybe the fact that pictures have more details depicted on the slide leads to more distinctive encoding, and that if we were able to make the words and the pictures equally distinctive, including the same number of lines and things like that, we'd get equal performance and recall of the slides, of the material. So it's possible the pictures are more memorable, but it's also possible that there's some extraneous variable that's causing it to appear as though pictures are more memorable. Okay, so our job when we design experiments is to try as well as we can to predict what might serve as a confounding, extraneous nuisance variable, and then control it. So remember way back at the beginning of this chapter when I talked about identifying variables and then controlling them, one of the variables that we seek to identify is the extraneous variable, the things that are not part of the experiment that we don't want to interfere with our independent variable, and then we try and figure out a way to control them. So we've got to exercise control over these extraneous variables. We want our results to be meaningful, and we want our results to be clear. We don't want other people to be able to look at our experiment and say, well, I can think of an alternative explanation right off the top of my head. Your horse can't do cube roots and square roots. You've got somebody standing behind him, poking him in his right flank when it's in your left hand, and in his left flank when it's in your right hand. Extraneous variable. We want to make sure that we don't have extraneous variables, that any nuisance variables that are present are having minimal influence. So how do we accomplish this task? Well, for one thing, don't poke your horse in the flank, right? Okay, but how do we do it in a real experiment? Okay. Basic control techniques. One that I've been talking about, randomization. Make sure that each participant has an equal chance of being assigned to either group, and that way you start out with groups that are basically the same. Individual differences are distributed around. Another control technique is to eliminate the extraneous variable. Just recognize it and then make sure it's not there. So, for example, if we have reason to believe that males and females will perform differently on a test, we might want to just go ahead and eliminate that possible nuisance variable and only test one of the sexes. Just eliminate it. Now some people go, well, that's biased. No, it's called control. When you're especially when you're new in a new area of research and you're not exactly sure what effect might happen if you include both sexes, take one of them out and just study one of the sexes. You can study your favorite one. You can study the one that you think will be the most sensitive to the independent variable. A friend of mine and I, when I was in graduate school, we decided we wanted to study defensiveness and what effect it has on cognition. She was the defensiveness expert. I was the cognition expert. And so we realized that females induce into a defensive mood more readily than males do. So we just studied females. The research had shown that they induce better. So we're like, let's not have a confound present. Let's only study women. It's not bias. It's not sexism. It's called elimination. Getting control over your extraneous variables so that the only explanation that's left is your independent variable. Constancy. Reduce the extraneous variable to a single value that is experienced by all participants. So if you're worried that, for example, the time of day might play a role in the participant's performance, get rid of variability on time of day and say everybody's going to have to take the test at the same time. it's constant. So all data will be collected between 11 a.m. and 1 p.m. or whatever, and everybody has to be that potential confound is held constant by eliminating it down to one single value, and everybody experiences the same thing. Now, other things that you can do oftentimes have to do with repeated measures tests. Balancing. Achieve group equality by distributing extraneous variables equally to all groups. So you are going to say, okay, maybe I'm worried that the males and the females are going to score differently on this test. So I make sure that each group is half male, half female. Or, let's be honest, when we are recruiting students as our subjects, we get an overemphasis on female respondents. So you just make sure that half of the males are in one group and half of the males are in the other group, and then the remainder of each group is made up by the females. Just balance it out. Just make sure that if sex might possibly be an extraneous variable, distribute it across the groups. That's what we call balancing. Counterbalancing is we control order effects in a repeated measures design by presenting the different treatment techniques in different sequences to make sure that if there's a carryover, it's experienced in all of its different variations. So let's talk about that briefly. I probably am spending more time on counterbalancing than I really should for most of your research and ideas and things that you'll do in the future, but it's always good to be exposed to these things. So a lot of times people think, well, I'll just do a complete counterbalance. All possible treatment sequences are presented, and that's fine if you only have like 2 treatments. Here we have the effects of contingent monetary reinforcement and music on exercise in college students. This is an actual study that I found in psychological science. And so for some of the conditions, they're going to be offered money for continuing to exercise, and in other times they're not going to be offered money. And some of the times they're going to get to hear music while they're exercising, and other times they're not. So it's 4 different conditions, and each participant has to experience each of these conditions. In a complete counterbalancing, when you've got 4 conditions, let's call this upper left 1, upper right 2, lower left 3, lower right 4. So you'd have to have some participants experience, complete counterbalancing would require that every participant experience every possible combination of orders. So they would have to experience 1, 2, 3, 4, 2, 3, 4, 1, 3, 4, 1, 2, 4, 1, 2, 3, 4, 3, 2, 1, 3, 2, 1, 4. Are you getting where I'm going with this? You'd have, I think it's 32 different conditions if you did complete counterbalancing when you start off with 4 basic conditions. So for a lot of us, we don't do complete counterbalancing because it gets really untenable really quickly. So for a lot of us, we just go right to incomplete counterbalancing, where a portion of all possible sequences are presented. So maybe I say, I give you 1, 2, 3, 4, 3, 2, 1, 3, 2, 4, just a few, right? Try and get away from it always being in the same order, but not necessarily give you 32 different conditions. What we're trying to get away from is sequence or order effects. Sequence or order effects refers to our confounded study where we can't figure out which of the treatments was the effective one. It could be the order that is critical rather than finding out that money plus songs produces the best performance. Maybe it's by the time I'm on the 15th combination and I'm still exercising, nothing's working anymore, right? It could be the particular order, the timing that's critical. So if we go music plus money, then control, does that produce better outcomes than if we go music plus money, control, then music? I mean, maybe the order is what's mattering. And so we want to get away from that interpretation by counterbalancing so we can eliminate that interpretation. Of course, there can be carryover effects, where the effects of one treatment influence the responses to the next treatment. So here's an carryover effects in attitude survey example. This is from an older study, so it's referring to the Persian Gulf issues that actually some of these seem relevant again. For a while there, they weren't as relevant, but so the target issue is people's attitudes about the Persian Gulf and the rights of the accused, welfare, abortion, defense spending, and Nicaragua. And a lot of you are probably going, what are you talking about with Nicaragua? But this is an older study. In the context set, one, they read about things having to do with Lebanon, the fear of crime, government responsibility, traditional values, arms control in Vietnam. In the context set two, they read about Iran, civil liberties, economic individuality, rape, Soviet threat, and Cuba. Okay, so what they're looking for is whether reading context set one affects your attitudes on the target issues in a different way than context set two does. Will the context carry over into your attitudes towards the target issue? We could look back at this little thing and say maybe the benefits of exercising with music carry over, and what we're seeing is that, yeah, I'm still performing well for money, even though really it's because I'm performing well as a carryover from having been exposed to music, right? That's what we're talking about. So one of the things we do with counterbalancing is get rid of these carryover effects. So everybody has the experience with each context before stating their attitudes, and we counterbalance and make sure everybody has the same kinds of experiences. What we're trying to avoid is the differential carryover, where response to one treatment depends on which treatment was administered previously. If you're trying to figure out whether your new treatment for depression works, so you have a within subjects design where your participants are going to experience Prozac for 6 weeks. They're going to experience cognitive behavioral therapy for 6 weeks, and they're going to experience aerobic exercise 30 minutes per day for 6 weeks. You could imagine that if the participants took it in the order that I just described, medication, therapy, then exercise, you might get an incorrect impression that exercise works way better than if the person experiences exercise first while they're still in the very depths of their depression or something, right? That's differential carryover effects, where the benefits that you got from having experienced the Prozac treatment might carry over and make the therapy work better, which then may carry over and make the exercise work better. So order matters. So we counterbalance to make sure that some people are getting exercise first, some are getting Prozac first, some are getting therapy first, and so on. All right. I may have belabored the counterbalancing a little bit, but hopefully one day you guys will be like, I needed to know that. All right, so that concludes chapter 6. So I will see you next in my explanation of weekly exercise 6.